All right, so this is section 1 of chapter 6 on the topic of research strategies. And in this section, we will discuss a number of different research strategies, including descriptive, correlational, experimental, quasi-experimental, and non-experimental. All right, so what is a research strategy? And we can define this term as the approach that a researcher takes in light of the goals that they hope to accomplish in their study. And this is, of course, very important because the strategy you choose will dictate the sorts of questions that your research can hope to answer. And life is all about trade-offs. You can't have the best of all worlds. And as we'll see, each strategy has its own challenges and its own advantages and disadvantages that we'll talk about in this lecture. So consider the following 3 questions listed here. So 1, what is the average amount of time spent on social media sites by adolescents? Okay. 2, is there a relationship between social media lurking, when you lurk on people's profiles, and adult life satisfaction? And 3, do changes in social media use cause changes in depressive symptoms in young adults? Now, all of these are perfectly good questions that are par for the course for the social sciences and for psychology to answer. But you may notice that these 3 questions actually can be placed into 3 different categories in terms of what sort of thing they are investigating. So for the first one, here you are looking at a single variable, the amount of time spent on social media sites by a certain group of people, adolescents. Okay? So again, you're investigating a single variable and trying to describe and measure that variable. Now in the second question, now you have 2 variables. You have social media lurking, and you have life satisfaction in adults. And here you are asking if there is a relationship between these 2 variables. Not does one cause a change in the other, but do they rise and fall together? Does a change in one accompany a change in the other? Is there a relationship? And finally, in the third question, again, you have 2 variables. You have social media usage and depressive symptoms in young adults. But here, you're going beyond measuring a mere relationship, and you're asking if these 2 variables are causally connected. Does a change in one variable cause a change in the other variable? So now you're investigating an explanation for the relationship and not merely describing the relationship. And so depending on what it is you want to know, depending on if you want to investigate a single variable, a relationship between 2 variables, or look for a causal relationship between 2 variables, these 3 questions will require different research strategies. And so the goal of this chapter is to discuss those strategies and what they look like. Okay, so let's begin by talking about descriptive research. And as the name implies, the goal of descriptive research is to describe the current state of the world. Well, okay, maybe that's a little too ambitious. You can't describe the world all at once. But maybe you can compromise and you can focus on a single variable that you care about, that is of interest to you. Uh, for example, how many friends does the average college student have? How many times do people check their phones every day? How many people volunteer for community service every year? How many homeless people are there in Los Angeles? Now, notice in all of these questions, what we're attempting to do is to investigate the current state of a single variable. So we're not concerned about relationships between variables. Rather, we are trying to take a snapshot of some characteristic for some group at a specific point in time. And so again, if the topic is social media use, you can ask, how much time do people spend on social media on a daily basis? And that is the sort of question that would employ the descriptive research strategy. Now, if you want to go beyond that, if you want to know, for example, is there a relationship between social media use and some other variable? Well, now you would need a different strategy because this approach, descriptive research, can't answer that. All right, so suppose you want to know whether people who spend more time on social media are also more anxious. Good question. And this question is asking about a relationship between two variables, in this case, social media use and anxiety. So let's talk about strategies designed to examine relationships between variables. First of all, to say that there's a relationship between two variables is to say that a change in one variable is accompanied by a change in the other variable. So it does not mean that the change in one variable is causing the change in the other variable. That may or may not be true. But a relationship simply means that these variables change together. Now, there are different ways of describing relationships. For example, a relationship can be positive, meaning an increase in one variable is accompanied by an increase in the second variable. Or a relationship can be negative, which means that an increase in one variable is accompanied by a decrease in the other variable. Also, relationships can be linear, meaning they can be described using a straight line. Or they can be curvilinear, so relationships that are not well described using a straight line. Imagine a relationship that looks like a hockey stick or a U as opposed to a single straight line. So here are some examples. So this would be an example of a positive linear relationship. So imagine that you have social media use on the x-axis and anxiety on the y-axis. So here, an increase in social media use would be accompanied by an increase in anxiety. Here we have a negative linear relationship. So in this situation, an increase in social media use would be accompanied by a decrease in anxiety. And here, all the way on the right, we have an example of a positive curvilinear relationship. So here, imagine that increasing social media use is not really accompanied by an increase in anxiety until you hit some threshold, at which point increasing social media use is accompanied by a spike in anxiety. Or you can imagine a U shape. Okay, imagine this being a U. So people that use very little social media have high anxiety. People that use moderate amounts of social media have low anxiety. And people that use high amounts of social media have high anxiety. So relationships come in many, many different forms and shapes. All right, so usually relationships are investigated by employing correlational research, in which two variables are measured for each individual in your study. Then the data are plotted, and the strength of the relationship can be explored and quantified. So let's consider this example here. So we have, let's say, 8 or 9 students. And for each student, we're going to collect two measures, two variables. One is Facebook usage. And I understand Facebook is now a boomer pastime. But back when students used Facebook, okay, so that's one measure. And the second one for each student is going to be academic performance. Okay, so two measures for each student. And the next thing you want to do is you want to plot your data. You want to visualize the data. Now, you always want to visualize your data. A graph really is worth 1,000 numbers when it comes to data analysis. And so in correlational research, typically you would use a scatter plot where you have on the x-axis, in this case, you have Facebook time, Facebook usage, from 0 to 5, least to most, and academic performance in GPA, again, from low to high. And just by looking at the data, without doing any fancy analysis, without knowing that much about research or stats, you can probably notice that there is a relationship. The data don't look to be random, okay? And specifically, we can classify this as a negative linear relationship. So we can see that people that use very little Facebook are doing really well. This student has a 3.8 and does not use Facebook very much. And this student uses a lot of Facebook and is down at like a 2.2 or something, okay? So now people will look at the data here, and they may be tempted to conclude that Facebook use causes a decrease in your grades. And while that is a plausible hypothesis, which may be true, this analysis here at this point cannot tell you anything about causality. This analysis can't tell you whether Facebook use causes the decrease in academic performance. You would have to employ a different research strategy if you want to answer the question about cause and effect relationships. Now, another approach to measuring a relationship between two variables involves comparing two or more groups of scores. For example, consider this data set here on the right, where you have high school grades from two groups of students, high income and low income. So you have two variables. One is income, high or low, and the other is grade. So here, one of the variables, in this case income, differentiates the two groups, and the second is used to collect scores for each person in the study. And the next step would be to see if there is a difference between these two groups, and if there is, then we can conclude that there's a relationship between income, or in this case family income, and academic performance as measured by these grades. Now, this is an example of comparing two sets of scores, but you can imagine a situation with three sets of scores. So maybe high income, middle class income, and low income. So when assessing differences between two or more sets of scores, we're going to describe three strategies that differ along several dimensions. One of those being scientific rigor and the ability to identify cause and effect relationships. Okay, so the first is called the experimental research strategy. And this is the strategy that you use if you wish to explore and identify the presence of a cause and effect relationship between two variables. So for example, let's say you want to know whether mindfulness meditation causes a decrease in anxiety. Now, if you employ the experimental research strategy, you would do something like the following. You would recruit a bunch of people from the population. Then you would randomly assign those people to one of two conditions. In one condition, they're going to meditate for some period of time. And the other condition, they won't meditate. Now, ideally, you want to create a situation in which these two groups are as identical as they can be, with the one exception of your independent variable, which is meditation, right? Do they meditate or not meditate? You want that to be the only difference between these two groups. And so then when you measure differences in anxiety following 2 weeks, a month, however long this goes on, if your two groups were identical to begin with, or very, very similar, then any difference that you measure logically can only be attributed to the meditation, because in every other respect, your two groups were the same. So again, that's an example of experimental research, and we'll talk more about this approach later in the course. So from a scientific standpoint, this is the most powerful, the most rigorous approach. This is a true scientific experiment. However, from a practical standpoint, there are many situations where this may not be feasible, or it may not be ethical to perform a true experiment. So while very powerful, this approach is somewhat limited in applicability, especially when studying humans. All right, so the second one is called quasi-experimental research. And here you are dealing with experiments that have most of the ingredients of a true experiment, but do fall a little bit short of being a true experiment and are therefore classified as quasi-experimental. So for example, imagine you want to compare two different programs for teaching calculus to high school kids. So you have program A and program B. And let's say you find two different high schools in your city, and one high school is assigned program A, and the second high school is assigned program B. And then after a year, you compare their math abilities in calculus. Now, there's a problem with this design. Specifically, it lacks random assignment to groups. You are using pre-existing groups of the first high school and the second high school. And so any differences that you observe in math abilities may be due to the program that they were assigned to, or it could be due to pre-existing differences that are present between these two high schools. And without random assignment, which is a critical component of a true experiment, you can't say for certain whether it's the math program causing the differences or some other variable that you did not control for by virtue of not using random assignment. Therefore, this would be an example of a quasi-experimental study. And finally, we have the non-experimental research strategy, in which you attempt to demonstrate a relationship between variables without trying to explain that relationship or say anything about cause and effect. So suppose you want to know whether levels of stress differ between lawyers and doctors. So you go out and you collect a sample of lawyers and a sample of doctors, and you use some scale to measure how much stress they experience on a daily basis. Now, in this situation, all you can say, if you find a difference, is that there's a relationship between stress and profession, in this case, being a lawyer or a doctor. But in this situation, you have not manipulated a variable and you have not used random assignment. And those are critical components of a true experiment. So this would be considered a non-experimental research strategy, which can only reveal the existence of a relationship and say nothing about cause and effect between the two variables. Now, you may have noticed that non-experimental and correlational research appear to be very similar. And they are similar in terms of what they aim to accomplish, which is to demonstrate a relationship between two variables without explaining that relationship. And so they differ only in the following sense. So in correlational research, you have one group of participants, one group of individuals, and for each person, you're going to measure two variables. Okay, so one group of people, and you measure two variables for each. Conversely, in non-experimental research, you have two different groups of people, and you measure one variable for each individual. Okay, so that's the difference. And otherwise, they are the same in terms of what they attempt to achieve, which again is demonstrating a relationship between variables. Okay, so we talked about research strategies and the different strategies that are available on offer and the pros and cons of each. Now, once you've chosen your strategy, you have to figure out the research design. And the research design refers to the specific details of how your strategy is going to be implemented. So there are a number of additional questions that you have to consider and answer before running your experiment. For example, will your experiment be on a group or on a single individual? So a single individual, that implies a case study, which allows for a more detailed and nuanced exploration of a single individual who's usually special or unique in some way. Or will it be on a group of people, which is more generalizable to the broader population? Secondly, will you use the same individuals across your conditions or different individuals? And here, the distinction is referred to as within subjects and between subjects design. So let me just give you an example. Let's say you want to know whether listening to music, some type of music, helps concentration. So do people who listen to music perform better on some sort of task, maybe math task or a reading comprehension task? Okay. Now, if you use a within subjects design, you would have the same people in both conditions. So you have your participants perform your task without music, and then at a later time, you have them perform some other task, similar task, with music. And you measure the differences in performance based on whether or not they were listening to music or not. And there are advantages of using within subject designs that we'll talk about later in the course. Or conversely, a between subjects version of the same experiment would be if you have two completely different groups of individuals, one in the no music condition and the other in the music condition, and then you compare their performance. Okay, and finally, how many variables are you going to stuff into your experiment? And in principle, you can have several independent variables and several dependent variables. Now, the more variables you have, the more complicated your study becomes, both in terms of analysis, the statistics, and also in terms of interpreting and understanding what the data mean. But in principle, if you know what you're doing, you can stuff more than 2 variables into your study. And next, you have to figure out the research procedure. And this gets even more granular and even more specific to the particular study that you're planning on running. So the research procedure is a step-by-step, precise, detailed description of this particular study that you are planning. And so you have to answer additional questions and solve additional problems. For example, how will your variables be manipulated and measured? So in the example of music and concentration, well, what music are you going to use? How will you measure concentration? What specific tasks will be used here? Also, how many people will be involved in your study? And finally, just exactly how the participants will proceed through the course of your study, step by step, with every gory, intimate detail brought to the surface. And lastly, you have to put some thought into how your data are going to be analyzed once you have collected your measurements. And the analysis options will depend on how your study was designed, and for example, the research strategy that you've chosen. So in the category of experimental, quasi-experimental, or non-experimental studies, where you are comparing groups of scores against each other, you'll probably use a t-test or an ANOVA, analysis of variance, to make those comparisons. For correlational studies, you will probably compute a correlation coefficient that quantifies the strength of a relationship between your variables. Or you may use a chi-square test for non-numerical data. And finally, for descriptive studies, you will probably compute a mean, an average of some kind for numerical data, or perhaps a percentage for non-numerical data. And we'll talk more about these tests in a lot more detail in the corresponding chapter on statistics.